Hi, my name's Karen. I'm a first-year graduate of Computer Science in the Technion and joined Cadence for a summer internship. I'd like to introduce a utility I created for users that write in E, the dependency graph. We frequently need to create a sub-environment of an existing one, to cut out all undesired files under a specific configuration, or to create an elib to share with other teams. A relatively new utility called the dependency util uncovers the dependencies in the environment in textual format. The dependency graph provides a graphical illustration of this information, assisting in understanding which files should be packaged together or which dependencies should be removed. For example, in this example, each node in the graph is a module, and each arrow represents a dependency. In this graph, the xtop module depends on the xchecker module. But hey, why should xmonitor depend on xdriver? This means xmonitor must always have xdriver in the environment. And now I know that's a dependency that needs to be removed. The tool is made up of 5 files, 2 E files and 3 Python files. I hadn't had any prior experience with E, but within a few days I was able to connect E code to Python using the Python interface for E. They really can work great together. In this case, the E files extract the dependency data from the environment, and the Python files receive the data and display it in the graph. In addition, we've provided a README file, which contains most of the information I will explain in this video, so you're welcome to reference it when needed. The 3 Python files are createGraph and graphaux, which contain the Python code that creates and displays the graph, and config, which contains configurable variables. You may modify these variables locally and affect the graph files that are created. All 3 of these files must be in the same folder. In order to run the tool, there are 2 prerequisites. The first is configured environment variables. These are in order to enable Specman to run Python files in general. The Python path variable should contain the path to the 3 Python files I just talked about. Additional information regarding the values of these variables can be found in the Specman reference. The second prerequisite is installed Python libraries. You may run this tool using any Python version, provided you have the following libraries installed. As soon as you have taken care of these 2 requirements, you are set to use the tool. To initialize the tool, you must run the following command. The command runs Specman with the correct flags and loads the dependency graph tool. No need to copy from here, the commands are all in the README I mentioned earlier. Notice that in my case, dependency graph E is in my current directory, otherwise I'll load it from its path. Afterward, load the modules in your environment to Specman. For example, I will load mytop.e from the My Environment folder. As you can see, all my modules are now loaded. Now we are set to create the dependency graph. There are 2 different graph options, a package graph and a module graph. A package graph will display the direct and indirect dependencies of packages on each other, while a module graph will display the direct and indirect dependencies of modules on each other. Let's start by creating a package graph. In order to run the command, we need to input the package we are interested in. In this example, it is IP4. In addition, there is an option to supply a blacklist of packages that we'd like to be able to hide in the graph. For example, all packages may depend on the common packages, so I'll use this option in order to toggle the display of my common packages, common 1 and common 2. An HTML file is being created with the graph and will automatically open in my browser. Now I have a visual depiction of the dependencies between the packages. Each node in the graph represents a package with its name underneath. Hovering over a node will show the package name as well. Each arrow represents a dependency between two packages, and hovering over the middle of the arrow displays the specific dependencies between the modules of the packages. At the top left, there's an option to display or hide blacklist packages. In this case, the common packages from the input we gave. I entered common 1 in the blacklist, therefore it will be hidden. At the top center of the page is a summary of data regarding the packages and dependencies. Now let's create a module graph. This graph type will display the dependencies in a more detailed form. If a specific module name is given, all related dependencies are displayed. If an asterisk is input, all dependencies in the loaded environment are displayed. Be prepared, that can mean a lot of dependencies. I'll be brave and create a dependency graph of all dependencies in my environment. The module graph allows us to view the dependencies in a more detailed display. This time, each node in the graph represents a module. At the top left, there's an option to display or hide standalone modules, meaning modules that aren't related by dependency to any other. Now we can focus on the remaining modules and dependencies. The nodes are color-coded by the package the module belongs to, with a legend to the right. The size of a module node depicts how many others depend on it. For example, many modules depend on common, therefore the common node is larger. Each arrow represents a dependency between two modules, and hovering over the middle of an arrow displays a specific dependent entity. If there are many dependencies between two modules, we'll see some, and then 3 dots indicating there are more, like in this case. Red arrows indicate a suspicious dependency, meaning a module is imported but not used. In this case as well, at the top center, we have some data regarding the modules and dependencies in the graph. Up until now, we have seen the package graph and the module graph in visual format. If we'd like to output the graph information into a text file instead, we'll set the toFile flag to true. For example, the information will now be written to a text file in a specific format that is specified in the README file. When writing to a file, there is no consideration to a given blacklist. And that's about it. The utility is accessible on GitHub at the following link. For additional information, you're welcome to reference the README file, and for further questions, please contact us via email, LinkedIn, and Facebook. Thank you for your attention, and we at Cadence hope you put this tool to good use.